Okay, so now for problem 11, we ask that which of the following equation, consider the following equation. Sodium plus an electron is a sodium. So like, it asks us which statement is true. So over here, this is basically that they gained electron, right? So then this would be defined as the ionization energy because it's a negative value. Because the ionization energy, which is IE, is defined as the energy that it loses electron, but over here it's a gaining of electron, so it's a negative value. So which was what defines this question. Okay, moving on to question number 12. We are given that sulfuric acid is industrially produced in large quantities. And it says that it can be produced in a multi-step process from elemental sulfur by first oxidizing the sulfur to sulfur trioxide gas and then bubbling the water to water. So they've given us two equations. And they've also given us the yield rate. And then now they ask that if this many liters of sulfuric acid is produced using this process, how many kilograms of elemental sulfur was used? So from this, we can see that there's a total of, you times 12 liters, which would be equal to 1.5 times 10 to the 4th mole of the sulfuric acid. So then since we can see that over here, the sulfuric acid, we first use equation number 2. So basically this is the SA goes to 8SO3 and this goes to 8H2SO4. So then now we have to calculate the yield rate. Oh, my bad. We have to calculate the yield rate. So the yield rate would be the moles. This is NSOH2SO4. So then equals this. So N of SO3 would be equal to 1.5 times 10 to the 4th divided by the yield rate, which is 0.531. And this would give us this many moles. And then now we have to also calculate the N of the S8. So the one we want is technically you just divide that value, divide NSO3 by 0.872. And then we get the final answer of 1040. No, we don't get this answer immediately, but then we get that NS8, oh my bad. We get that N of S8 would equal 4,000 moles. So since we got this value, then we can just calculate the molar mass and times it, which I won't calculate, but it will be B. Okay, this is a bit messy. Okay, moving on. Alright, so question number 13, we can see that they've given us this structure, and then they want us to ask which one's correct. Let me see if I can enlarge my screen here. Okay, so they've given us this structure. So I'll just draw everything, I'll redraw the diagram on the next page. Over here. Actually, no, I'll just analyze it over here. So over here, we see these arrows indicated. So over here, we'll start with the O over here. So this O is connected to a H, and 2 a carbon. And then it has 2 lone pairs of electrons. So then this shape, since it has 2, this would be a bent, or V-shaped. V-shaped. Now we move on to this end pointed over here, which would be, it's attached to a carbon, and it's attached to 2 hydrogen, with 1 lone pair. So then this would be a trigon pyramidal middle structure. And then we move on to the sulfur. The sulfur has connected to 2 carbons. And then 2 lone pairs. So this would also be a bent. This would also be a bent. And then finally we move on to the carbon. The carbon over here. So since we already showed that it's connected, and then there's no lone pairs, we can see that there's 1, 2, 3 electron domains. So the hybridization would be a sp2. Because there's 3 domains, then it means that there's going to be sp2 for the hybridization. Now let's go check out the answer choices. So it tells you that the bond around the indicated O form a trigonal planar. But then as we have shown, it is a bent. So A is incorrect. It also B option is the bond around the indicated nitrogen forms a trigonal pyramidal, which is correct. And the indicated C is sp3 hybridized. This is wrong. This is wrong because it's sp3. This is sp. So then there's only the option E left. And we can see that the N form a trigonal pyramidal shape. This is correct. And it's a sp2, so this is also correct. Okay, moving on. Question 14 asks us, which of the following acids has the strongest conjugate base? So for an acid to have a strong conjugate base, a strong acid gives a weak conjugate base. So we want to find a weak acid which would give us a strong base. So over here, this is a strong base. This is a strong acid, sorry. This is also a strong acid. This is also a strong acid. So the only weak acid here is option D. Okay, now let me see. Question number 15. They've given us a reaction A and B. And the concentration of A is found to vary with time as shown in the graph. The rate constant is given to be 2.78 times 10 to the -5 second -1. So we can see the graph over here. So since we can see that the A is a straight line, the rate reaction of A is a straight line, a linear line, which means that A is 0 order. A is 0 order. So since A is 0 order, then that means the unit this would mean that the slope of the line would be equal to the rate. So we can find that the slope of a line is 1.33 times 10 to the -5. And then we can see that, so basically we have known the rate 1.33 times 10 to the -5 equals the rate constant, which they've given 2.78. 2.78 times 10 to the -5. And then we times the B. So you divide these, we can get 0.48 moles per liter. Okay, moving on to question 16. They are told that we have given a reaction at equilibrium. We're given the concentration, and the pressure is increased by adding neon to the system. So over here, we are given that P rises by adding neon. But then, since the equilibrium won't shift, because the same gas molecules, it's due to like the same gas molecules at both sides, and partial pressure for each gas, which is P partial, equals NIRT divided by V. So then this thing won't change. But only like, yeah, so like nothing changes over here. The equilibrium doesn't shift. Question number 17. We are given this added 1 liter of 0.5 mole per liter silver nitrate solution to 1 liter of sodium chloride. Also, they are told that the equation for this is right here. We have, so since they've telling us that the silver ions have all disappeared, then that means the silver ion has got to be at the bottom. So we can instantly take out B, C, D. And for the remaining, I'll list the chart. Ag plus, Na plus, Cl minus, and NO3 minus. So over here, we're known that this is basically 0. This is 1. This is 0.5. This is 0.5. And you have to divide by 2, 2, 2, 2. So then we would be able to get that the concentration at the end with the equation, because we can see that this is a perfectly balanced equation. So then we don't have to even balance it. This is already balanced. So then the concentration will be 0, 0.5, 0.25, and 0.25. So we can see that the answer is going to be E. Okay, question number 18. We're given that they added this many acid and reacts with this many base. So what is the resulting pH? Over here, this question isn't exactly really well defined, as we can see that we have a total number of 0.05 times 0.75 mole and of glutamic acid, and we have 0.05 times 0.25 moles of sodium hydroxide. So over here, this is a total of a 3-to-1 ratio. So we're left with, we can see that this is equal to, so there's 0.0375, and the other one is a negative not negative, sorry. That's for the calculations later. 0.125. So then the total amount reacted, so there's going to be there's going to be a total of 0.025 of the glucamic acid remaining. And then this is going to become 0 as it reacts everything with the acid. So over here, we can see that, as we know, pH, we can estimate pH as the pKa value plus the log of base over acid. So from this we would get, oh no, sorry, not base over acid, acid over base. From this we would get that it's roughly around 1.79, but we don't see the answer, so we're going to assume that this is a rough estimate. So then we can instantly choose the question number E. Okay, now let me see. Question number 19. Over here, they told us that it changed from an acid, it formed a product, and then its new functional group. So what type of reaction is this? So we can see that the original water has gone into the water has changed into this bond. So this would be a dehydration. And then the difference between substitution and elimination is that basically it eliminates the H2O, so then this would be an elimination. Question number 20. Okay, so first they've given us an equation, but they told us that it's unbalanced, and we're given the heat difference. So the balanced equation would be 4NH3 plus 5O2 4NO plus 6H2O. This is a balanced equation. And then over here, we can see that this is 3 NH bonds. This is just a O bond. This is a NO bond. Sorry, 2. And this is 2 OH bonds. So after doing all the calculations together, we can see that using these values, we can find that it's 457. No, 487, sorry. Moving on to question 21. Where they told us that there's an acid with an unknown base of concentration. Or they told us that we added 100 milliliters, so we have a total of 0.01 mole of the acid. And we're given that 200 mils of the unknown, so we have 0.05 of the base. Acid and base, okay. So they told us that the pH is 10.5. So then we can instantly tell that this is so the base would be left with 0.04 of the base. And we have to also divide by the original, which is 100 grams. No.